Graphing Quadratic Equations, and we're going to focus on line of symmetry and vertex. So let's go through some vocabulary real quick. We have vertex is the maximum or minimum point of a parabola, and we'll have a maximum point when the highest point of a parabola, when it opens downward, will be at the vertex. And we'll have a minimum point, the lowest point of a parabola, when it opens upward, and that will be at the vertex. And our most important thing of the day we have here is the axis of symmetry, is a line that passes through the vertex, having the equation about which the parabola is symmetric. And our formula to find axis of symmetry is x equals negative b over 2a. And the graph of a quadratic function is a parabola, and the parabola can open upward or open downward. If the parabola opens upward, the lowest point is called the vertex. Oops. When the parabola opens up, the lowest point is called the vertex. And when the parabola opens down, the vertex is at the highest point. It would be at the maximum. So we can have parabolas that open up or parabolas that open down. And standard form of a quadratic function is a times x squared plus bx plus c. And this a value or lead coefficient tells us a lot about our graph. If that a value is a positive number, the graph of our parabola opens upward. And if the a value is negative, then we have a parabola that opens downward. So another way of saying that the a value is positive, we can just say a is greater than 0 in math terms, or a is less than 0, meaning we have a negative number, would indicate if a is negative, we have a parabola that opens downward. And a line of symmetry, parabolas have a line of symmetry about them. If we drew a line down the middle of a parabola, we could fold the parabola in half. So I could take a line of symmetry and draw a line that would go exactly through the middle of the parabola. We call that the line of symmetry. And a line of symmetry cuts it into two equal parts that are congruent. They're the same size and shape. So we could actually take our parabola, fold it over that line, and it would perfectly match up with the other side. And we can do that with a parabola that opens upward or downward. And the line of symmetry always passes through the vertex. So if we're looking to find the line of symmetry, and we have a quadratic in standard form, we can use x equals negative b over 2a. That will give us the line of symmetry. So let's say we have y equals 3x squared minus 18x plus 7. To find the line of symmetry, we could use 18, negative 18, over 2a. 2 times 3. So 2 times 3 is 6. 18 divided by 6 is 3. So our axis of symmetry, or our line of symmetry, is going to be the vertical line at x equals 3. So we know the line of symmetry always goes through the vertex. Thus, the line of symmetry gives us the x-coordinate of the vertex. To find the y-coordinate of the vertex, we need to plug the x value into the original equation. So once we find the line of symmetry, we can now use that line of symmetry to find the vertex. So let's say we have a problem like y equals negative 2x squared plus 8x minus 3. We want to first find the line of symmetry, or axis of symmetry. We're going to use x equals negative b over 2a. We substitute in 8 for our b value. We substitute in negative 2 for the a value. Negative 8 divided by negative 4 gives us 2. So we have the vertical line at x equals 2 for our line of symmetry. Then once we have that line of symmetry, we have the x value. We can take that x value, go back to the original equation, and everywhere I see x, I can replace it with 2 and solve for y. So when I calculate this right side, it's going to have y equals, and this number is going to give me the second part of the ordered pair of the vertex. So I could do 2 squared is 4, times negative 2 is negative 8, 8 times 2 is 16. So negative 8 plus 16 minus 3, and I get a y value of 5. So I had already found the x of 2, substituted in, and now the y is 5. So the vertex is at 2, 5, and that vertex is going to be our maximum or minimum point. Well, actually, I know if I have a negative a value that this is going to face downward, that this 2, 5 at the vertex is going to be at the maximum. So you guys pause the video here, find the axis of symmetry and the vertex. So two things we're asking for. First, find the axis of symmetry, then use that axis of symmetry, go back, substitute into the original problem, and find the second part of the vertex. Pause the video here. All right, welcome back. So when we substitute in our negative b over 2a, we would get x is 1. So we have the vertical line at x equals 1 for our axis of symmetry or line of symmetry. Then to find the vertex, I'm going to take 1, I'm going to put it into the original equation. Everywhere I see x, I'm going to replace it with 1 and 1. So I have negative 4 times 1 plus 8 times 1. Negative 4 times 1 is negative 4, 8 times 1 is 8, then negative 4 plus 8 minus 9 gives us negative 5, so our vertex is at 1, negative 5. All right, so let's write down the steps that we're going to go through to graph a quadratic. Step number 1, determine whether the parabola opens upward or downward. That's going to tell us a lot about what we're looking for in our final answer. Step 2, find and draw the axis of symmetry. Step 3, find and plot the vertex. Step 4, plot points using a table. Choose one or two values less than the x-coordinate of the vertex, then find the corresponding y value. So we're still using t-tables here to get additional points that are right around the vertex to finish our graph. So axis of symmetry and vertex alone will not draw our graph. We're going to need to use tables as well. Step 5 is after I found those points from step 4, I want to reflect the points plotted from step 4 over the axis of symmetry. So these are like some free points without doing a lot of math or anything. We can just take points we found on the left side, use that axis of symmetry, flip them over it, and get additional free points to draw our parabola. Step 6 is to draw the parabola through the plotted points. All right, so we have y equals negative 4x squared plus 8x minus 9. We already found our line of symmetry at x equals 1 and our vertex at 1, 5. So if my line of symmetry is at 1, I can draw a little dotted line there at x equals 1. Vertex at 1, negative 5. I'm going to plot the point at 1, negative 5. Now, I'm going to need some additional points, but with parabolas, it'll get off this graph really quickly. So I'm looking to go just maybe one place on the x to the left of where I'm at. So I want to put in an x of 0 because I don't want to go very far from this line of symmetry because these graphs get quickly off the coordinate plane. So what x value is just to the left? I want to use 0. So if we put 0 into my original equation, negative 4x squared plus 8x minus 9, I put 0 in. Well, multiplying by 0, a lot of the problem goes away quickly, and I have y equals negative 9, so I have the point at 0, negative 9. So 0, negative 9 barely fits on my graph, so it'd be nice to have a couple more points, or at least another point, but in this case, I'm going to be off my graph too quick. So I'm going to put on 0, negative 9, and then I have this line of symmetry. If I have a point 1 to the left, if I flip that over my line of symmetry, I'm going to have an additional point over here at 2, negative 9. Then I'm going to connect those together and draw a parabola through the plotted points. All right, so you guys try this one on your own. We have a line of symmetry at 2, a vertex at 2, 5. So you're going to need to graph this, and you'll need some additional points from a t-table. All right, welcome back. So if I put on axis of symmetry at x equals 2, I'm going to draw my line of symmetry there, my vertex at 2, 5. Then I'm going to need some additional points. I just want to go maybe one place to the left, and I'm going to use an x value of 1 in a t-table. Put 1 into my original equation, so I have negative 2x squared plus 8x minus 3. I put 1 in, so 1 squared is 1 times negative 2 is negative 2. 8 times 1 is 8. Minus 3 is 3. So then I have a point at 1, 3. Then I could reflect that point over and get an additional point, get that free point over there. And then let's say this one actually has enough room. I could go over one more place from the line of symmetry. I could put 0 in. Well, if I put 0 into that original equation, this zeroes out, this zeroes out. I just get 0, negative 3. Well, 0, negative 3, 0, negative 3 would be right down here. And then I could put a point there, and I could reflect it over and have an additional point here. And those would be great to graph in. A couple points would be much better than what's shown here. And my parabola would look like that, except for I have a point here and a point there. So you want to draw the parabola through the dotted points to make your graph of your quadratic. So is that vertex at a maximum or a minimum point? Well, since this quadratic is facing downward, this vertex at 2, 5, that is definitely at a maximum point. And I hope that helps you guys get started with graphing quadratics. Have a great day. OUT spells out.